Second? Okay. Alright, so we'll continue from where we left off. Hey, come on. So last time we were looking at tangent line. So next lesson. What's wrong? There we go, that's better colour. Tangent, first principles. Now, last time we saw a technique on how to find the slope of the tangent line, but only for special cases, when we have a quadratic. Because when we have a quadratic, we can use the discriminant, because we know that if it's a tangent line, it should only have one solution, and we can use the discriminant. But what do we do if it's not a tangent line? If it's not a quadratic, if it's something like a cubic. So let's take a simple example. Let's say we have y equals x cubed, and I want the slope of the tangent when x is 1. By the way, if x is 1, what would y be? 1 also. Okay. Graph would actually help a whole lot here. Now, I should point out before starting this, when it comes to the exam, it's okay. When it comes to the exam, this lesson is not common. In fact, it's quite rare. But I think it would be something that would come up soon, because it's been a long time since I've seen this in the exam. I haven't seen this in the exam for years, so it feels like it's due to come soon, okay? So when you're doing past papers for revision, you might not even see this in the past paper, but I really think it could come up for you, okay? So maybe you should write some note on the top of the page in your workbook, not in past papers, or something like this, because when you're practicing you won't come across this, okay? So just make note of that, please. Okay. Now let me graph my function here. Fx is equal to x cubed. And so I have y equals fx. Graph that. And there's the graph. And let me zoom in a bit. This way. Okay, so you can see there's the point 1, 1. And we want the tangent line there. If I want to use equation of the line, how many points do I need? I would need 2 points, don't I? But I only have 1 point. So what I'll do is I'll first approximate. What I'll do is I'll take another point that's really close to 1, 1. So let's just say 1.5. Can you put 1.5 in on the calculator and cube it? What do you get? Well, let's see, it's 9 over 4, isn't it? 1.5, 3 over 2 cubed, 27 over 8. Is it? What's it as a decimal? 3.375. Okay, what's the slope here? Well, that would be 2.375 over 0.5, because it's the difference of the y's over the difference of the x's. And what's that, please? It's nearly 3, like 2.6. Oh, so sorry, 4.75. Okay. Now let's take another point. Let's do, for example, 1, 1, and let's say 1.1. What's the y going to be here? What is it? 10, 11 over 10, 100, 1.21? Oh, I'm way off today. 1 point. Okay, and what's the slope again? The slope would be 0.331 over 0.1. Hey guys, why are you late? Come on, hurry up. Another minute or two, I wouldn't have let you in. Late again? You too. Why is it so difficult for you to be here at 9 o'clock? Just get up 15 minutes earlier. What's this, please? It's 3.31, isn't it? Okay. So let me show you on the graph what's happening. Let's see. I actually don't know if we have a function here to draw the line. No, I'll have to draw it myself. First, we took 1.5 and whatever the other number was. Oops, sorry. That should be at 1, 1. Is that a tangent line? No, because it cuts twice. Then the next number I took was, what was it? 1.1 and whatever the y value was. Is that a tangent line? No, because again, it still cuts at 2 points. But what I'm doing is, I'm moving my point closer and closer to 1, 1. So it's like I have 2 points. I know it's not a tangent, but if I move them really, really close together, then it does become a tangent, when the 2 points then meet and become 1 point. Okay, so that's what's happening here. Let me actually draw in the tangent line. Tangent fx x1. Oh no. Yeah. Now there's the tangent line. What's the slope here? It's 3. And there's the tangent line there. And if you look at my slopes, what did I get the first time? I got 4.7. And then the second time, 3.31. So I'll let you do the next one. Do 1, 1, and then the neighbour point is 1.001. So make it really close and tell me what you get for the slope of this line. Huh? No, use my number now. 1.001 for the x. So, Hussein, what I'm looking for here is 1, 1 and 1.001. Okay. What did you get for the slope here? 3. Exactly? No rounded? Not like 2.9999? Oh wow, okay. So exactly 3 then. I have a feeling though that it's not exactly 3, but the calculator can only go to 9 digits, is it, on the screen? Actually, yeah, well the calculator's saying it's 3. I'm saying it's not exactly 3. Let's calculate it here. Okay. So we have 1.001 cubed. Okay. So our formula is 1.01 minus 1, that's what you should have, and then 1.01 cubed minus 1. Okay. Ah, I typed something in wrong here. Huh? Oh, thank you. Okay. There we go. Approximate. Yeah, so it's not quite 3. It's 3.003. But what's 0.003 between friends? So, what I'm trying to show you here is that you can get a very good approximation for the slope of the tangent, but we can actually do better than that. We can calculate the limit here. What word do we use here to describe this sequence I'm making of what was it, 4 point something, 3.3, 3.003. The limit is 3. Convergent. So we can make a convergent process to get to the answer, and that's what we're going to do. So we start off by saying we take x, well, actually let me use numbers. We had 1 and 1, and our neighbour point was 1 plus a small number. I'll call that number h. And then what would the y value here be? 1 plus a small number cubed. Can you see that? So this is like 1, 1, and then 1.001 and 1.001 cubed. If you want the slope, you know how to do that. It's 1 plus h cubed minus 1 plus h all over 1 plus h minus 1. Huh? On the top? Oh, sorry, thank you. Minus 1. Okay. Now, if I cube out the top, I get 1 plus 3h plus 3h squared plus h cubed minus 1. And then on the bottom, I'll get h. The 1's cancel on the top, so I'm left with h cubed plus 3h squared plus 3h. The 1's cancel all over h. That's h squared plus 3h plus 3. So what I've done is I've made up a formula for the slope of the tangent. For this example, slope of tangent equals h cubed plus 3h plus 3. So in my last example, what did I use for h? 0.001. Okay. Put 0.001 into that and see what you get, please. Sorry, I'm really not doing well today. That's h squared. Okay, can you put in 0.01, Hussein, come on. Tell me what you get.
2.00301.
Which is the exact number that I had up a moment ago. If h gets smaller and smaller and smaller, what do you think the limit here is? H is getting smaller and smaller and smaller. What do you think the limit here is? If you look at this, it's 3. Why is that? Yeah, because the h is getting smaller. These two pieces will get smaller, won't they? Leaving you with only 3. So the limit is equal to 3. And that's actually the slope of the tangent. Because what's happening in this limit case the 2 points have become 1 point. So the answer for this one is exactly 3. Okay. Now let's put down a general formula. Can I scroll down? So let's suppose that it wasn't x cubed. Let's suppose that it was fx. And let's suppose that the point wasn't 1. Instead, let's just say the point was x. The formula for the slope of the tangent would be fx plus h minus fx all over h. But then what you have to do is at the last step consider what happens when h goes to 0. In other words, calculate the limit. So we do that at the end. Where did this formula come from? Well, if I draw a quick graph here, this point here is x, and the y value would be f of x. And if this point here is x plus h, then what's the y value? F of x plus h. So these are our 2 points. So I say y2 minus y1, that's the top, over x2 minus x1. So x plus h minus x is h. And this is what you might call the first principles formula. This formula here will let you calculate the limit. So let's do our first example of using this formula. The slope of the tangent at x equals 2 on x squared as an example. So we want to find the slope of the tangent here. So let's go through the process. Okay, can I scroll down? Okay, so here we have to use our formula. The slope would be f of x plus h. So in that case here it would be x plus h squared minus f of x, so minus x squared, all over x plus h minus x. Yeah, and just to be clear, that's the f of x. That's the function, the curve. On the top, I get x squared plus 2xh plus h squared minus x squared all over h. The x squareds cancel, and I'm left with 2xh plus h squared over h, which is 2x plus h. Now, I need to look at the limit when h goes to 0. So if I make h smaller and smaller and smaller and smaller, what am I left with? 2x, because this is disappearing. But I know what the x is. What's the value for x? 2. So this here is 4. Now let's go, I'll go back to this in a moment, but I want to graph that so you can see. So we have here x squared. There's the graph. And what's my point? It's point 1, isn't it? Or was it 2? Sorry, it was 2. So let's find the tangent for x squared when x is 2. And what's the slope here of this tangent line? 4 is the slope, isn't it? Which is exactly the answer I got here. So if I just graph this now in, there's my tangent line. And here at the point, this line has slope 4. Okay, so this method of finding the slope of the tangent line is called the first principles method. You can see it's not too long. you mostly have to practice expanding that you've learned in the chapter on sequence and series, the binomial expansion. Okay. Yep. Yeah. Here, yeah.
It's supposed to be over h. What's x h minus x?
This here?
Yeah.
Oh, that's from the formula. Over h. Oh, I'm sorry. I wrote unnecessary terms. Yeah. I should have just written h. Forget about the x plus x business. Well, it's fine to leave it in. It was unnecessary. If it confuses you, just remove it. I shouldn't really have it there. Okay, let's do another example of this. In fact, let's do one from the book. Okay, so the first one there. You got that? Yeah. The first one there. We have a simple one here. 8x. And what's the point? Well, we don't know what it is. Now, just to be clear, this symbol here, this also means roughly the slope of the tangent. Okay, so in other words, it's the part before you make h is 0. So in the last example, that's this piece here. It's what you might call the approximation, okay? It's roughly the answer. It's not exactly the answer, it's roughly the answer. In other words, it's this step here. So in question 1, I don't want you to worry about making h 0. So our formula for this would be fx plus h minus fx over h. So that would be 8x plus h minus 8x all over h, which is 8x plus 8h minus 8x all over h. What will that equal? Well, that cancels that. And what am I left with? 8. Now that's not too surprising. What type of curve is this? What type of curve is this? Yeah, what type of shape is it? It's a straight line. So if you imagine drawing a tangent to a straight line, what would it look like? The same line. So the slope of the tangent here is the same as the slope of the line. What's the slope of the line? 8. And what answer did I get? 8. Okay. So that's not, maybe that's not too surprising. But let's look at one which has something a bit more complicated in it. I want to leave that one for our homework. I'll just do one more of these. I'll just do minus x cubed. Okay, scrolling down. So now if I have fx equals minus x cubed, my formula for the approximate slope of the tangent is fx plus h minus fx all over h. So in this case it would be minus x plus h cubed minus x cubed all over h, which you get minus x cubed minus 3x squared h minus 3x h squared minus h cubed plus x cubed all over h. That cancels that. Notice something's always happening here. Notice how the first and the last always cancel. That should happen. So you're left with minus 3x squared h minus 3x h squared minus h cubed all over h. Cancel makes h makes squared. So you're left with minus 3x squared minus 3x h minus h squared. So, yeah. So this result means if you give me an x and I put the x into this formula with a small number for h, I can tell you roughly what the slope of the tangent is. So let's take an example. I'd like you to tell me the slope of the tangent roughly if x is 1. And choose any small number for h that you like. Okay? So for this formula, x is 1 and a small number for h. So tell me what you get. Okay. So does anyone have a numbered answer here?
Minus 3.0321.
Say again, what you get?
Minus 3.0321.
Are you sure?
3.
Yeah. Okay. Well, I'll put a number in now and see for an example. Do you need to talk to everyone or just? Yes.
Hi, I'm sorry to interrupt. Just to say, on Saturday, there is a social outing to the National University of Maynooth. I think Sophie has been in contact with you all about it. I know some of you, or a lot of you right now, may have no interest in studying in Maynooth, but you really won't be making that decision until later, and later there won't be the time to go and visit the universities. So this is a really good opportunity to go along on Saturday and get a feel for the place, talk to lecturers, talk to other students, and see really, is it somewhere you could imagine studying. Maynooth has an excellent reputation. A lot of our teachers have actually studied there. And even if you never end up studying there, it's really nice to go in and see an Irish university and see how it works and get an idea of it. Also, right now you might be thinking, I won't be going to Maynooth, I'm going to study X, whatever, I'm going to study medicine in RCSI. And that would be your first choice, that would be your dream, and we will support you in getting that. But as the time comes closer, you're going to have to make a second choice, a backup choice. And you know, every year we have students who intend to study medicine, but end up studying biomedical science or genetics or other science-related courses in another university instead. That's just how it is. So we're not saying you need to abandon your dreams of medicine, but you also need to consider what would you be happy doing if the medicine dream doesn't work out. And to get an idea of that, you need to look at all the options that are out there. Okay? So we really strongly advise that you go along to the trip on Saturday. You'll also get to visit the visit the town of Maynooth and get out and see the world outside of Dublin. Okay? Dublin is not the best part of Ireland.
Maynooth is very nice. You know, just the town itself. I've been there a few times. It's a really nice town just to see.
Yeah, really old campus as well. It's lovely, isn't it?
Yes, it's very nice, very nice.
Okay, I won't lay out more. I know that the event website, the link that Sylvia sent you isn't working, so you need to email her directly. Also, for medicine students who I spoke to on Monday, I know I said I would email you on Monday with that information, but unfortunately I was waiting for a response from UCLan and that didn't come until late in the evening on Monday, and I was sick yesterday, so I was sent on that information this morning, so apologies for the delay. Okay? Okay. Thanks for that. Thanks, Stephen.
Okay, so you got, was it minus 3.001?
Minus 3.0.
Yeah, so in other words, roughly minus 3. Now that would be question 1. The only difference between question 1 and question 2 is in question 2 in the book, I'll just pretend that this is now number 2, you have the extra step. So in number 2, they would like to know exactly what the slope would be. So now you just make limit h goes to 0. So in that case, what would you get here? Minus 3x squared. Now if I put x as 1, what number do I get here exactly? Minus 3. What letter represents slope? M. Okay, so this is the formula for the slope if you know h. Oh, sorry, if you know x, the point. But we don't use the letter m anymore for slope of tangent. when the limit has been applied, we now use dy dx, which some people have seen before. So from this point on, when I say dy dx, it means slope of tangent. And this, yes, this is called the first derivative. And the first derivative is the slope of the tangent. In other words, the slope of the tangent is the approximate slope of the tangent by using 2 points. Then you make the 2 points become 1 point by sending h to 0. So you have two formulas for today. You have this formula, which gives you the exact slope of the tangent, in other words, the exact derivative. And you have this formula for the slope, the approximate slope of the tangent. The slope of the tangent is approximately fx plus h minus fx all over h. So we need to use this always, and then we need to use this when we want the exact answer. Yes?
So let's use change of x instead of h.
In which formula?
First principle.
Yes, that was not my mistake, but that's what I was thinking earlier when Ali asked me about in the denominator I had x plus h minus x. In my head I had change of x. It's the same thing as just having h though. So it is the exact same thing. Okay. So let me give you one to try, and then I'll give the answer. Oh, sorry. Did you got this written down? I'll give you one to try. Okay. What is the first derivative of minus 2x squared? So in other words, give me a formula that tells me what the slope of the tangent is if you know a point x. So I'd like you to use first principles for this. Tell me what the answer is, please, okay? I'll give you a minute to do it, and then I'll do it on the board here. And by the way, in the exam, like I said, you could get this one. The question would say, what is the first derivative of minus 2x squared by using first principles? You got it? What did you get? Yes. Oh yeah, but make the h 0.
Minus 2.
Minus 4x.
Minus 2.
No. Minus 4x. Minus 4x?
Yes.
Yes.
Minus 4.
That's what I said. Minus 4x. Let me do the answer now. So the formula, roughly, the slope of the tangent is fx plus h minus fx over h, which in this case is minus 2x plus h squared minus 2x squared all over h. Taking care with the signs, please. Minus 2x squared minus 4xh minus 2h squared plus 2x squared all over h. Cancel, 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 and I'm left with minus 4x minus 2h. That is roughly the slope of the tangent. So exactly the slope of the tangent would be the limit when h goes to 0 of the answer I just got, which in this case will be minus 4x. So when x is 1, what's the slope of the tangent line? And when x is 2? Minus 8. So let me graph that when you're ready. Physics students, remember when we did the velocity time graphs? What does the slope of the graph represent? Acceleration. You now have a technique to calculate the slope if the graph is not a straight line, if it's curved, which we haven't done. Okay? So in other words, the first derivative of that graph, the velocity graph, is acceleration. Okay. Let me graph that now. Okay, what was my function, please? Minus 2x squared. Sorry, the original. Yeah. Now if I graph that, here we go. There's my graph. Using your answer, what did we say the slope would be if x is 1? Yeah, so let's calculate that, or let the program calculate that. Tangent minus 2x squared, x is 1. Simplify, expand that. Okay, and what's the slope? Minus 4. And when I graph that, there it is, minus 4. Now, when I put x is 2, what's the slope of that tangent line? What did you say? Minus 8. So let's have a look. If I expand that, simplify, expand, you can see it's minus 8. And let me graph that one again. And see, there's the tangent line. Now, if you look at your answer, what value of x must I choose so that the slope of the tangent is 0? So look at your equation, the answer at the end. What's your answer at the end? Minus 4x. So what do I choose for x to make that 0? 0. So if I get the tangent line now at 0, I should get 0. What type of line has slope 0? Yeah, but which direction? So you're expecting this to be a horizontal line. What's spelling? Thank you. Tangent 0. And of course, in this case here, if I try to graph that, it won't show me anything because there it is there, just the x-axis. But this gives us an important idea. Let me draw another quick one here to maybe demonstrate a bit more. Let's take minus x squared minus x minus 1. Graph that. Actually, let me make it a bit more extreme. Minus 5. Yes. Okay. you see here, this is the maximum point on the curve, isn't it? About here. But if I draw a tangent line at the top, what slope do you think it might be? It'd be 0. So if I draw a tangent line here, it'd be 0. Now, do we know how to find the maximum? Now, we do know how to find the maximum from our lesson on completing the square. So if we complete the square here, we should, when we put that into our answer for the slope of the tangent line, we should get 0. So what I'll do is I'll pick one here that's easy for completing the square. In fact, let me write it in completed square form already. X minus 1 squared minus 1. Okay, expand that. Expand. Graph. Alright, there's my quadratic. What is the point when it's maximum? What's the value for x and y? Minus 1 and minus 1. Oh, sorry, not minus 1. 1 and minus 1. Now, let's get the slope of the tangent. You know how to do that, okay? So I will just get the program to get the answer, but you've just done a couple of examples for me. So using our formula, we can get it here. Tangent minus x squared plus 2x minus 2, x is x. No, that didn't work. Alright, well, I'll just use my formula. So watch carefully, please. So what's the formula? Fx plus h minus fx all over h. So I'll just get the program to substitute it in and simplify, and you'll end up with that. And then what do I make for h at the end? 0. So I'll just, I will now calculate the limit as h goes to 0, and I get here 2 minus 2x. Okay. What did you say was the point where there's a maximum? 1 minus 1. So what's the x value? And 1. Yes? Now this is the slope of the tangent line, isn't it? If I put x as 1, what do I get here? 0. That's not an accident. At the maximum, the slope of the tangent is actually 0, always. So if I draw this now, watch the magic. Oh dear. That's not magic at all. What's gone wrong? Did I type this in wrong? Oh yeah, no, sorry, I know what I did wrong. I didn't put in my x. Sorry. No graphy bad. Let's try that again. Alright. Here I put in x is 0. And you see that I get 0. Sorry. Try that again. Thank you. X is 1. And I get 0. There we go. Yeah, there we go. And wait. Now I'll get the tangent line. Tangent minus x squared plus 2x minus 2 when x is 1. So let me calculate that, or the program calculated. You get that there? Okay, so if I graph that, there we go. That's what I was looking for. Can you see that? There's the tangent line running along the top of the curve. I'm doing a lot more now than what I need to for this lesson, okay? I'm just really trying to get you to think about tangent lines, slope of tangent lines, and how the tangent line changes, becomes 0 at the top, and then changes as it moves back down the curve. Yes, Joshua?
The tangent line doesn't look like 0. What's the y?
Yeah, but the tangent line is not 0, but the slope of the tangent line is 0. Because what's the slope of this line? Well, 0, because there's no x in it. It's like this. 0x minus 1. That's this tangent line here. Its slope is 0. Yeah. Anything else? No. For the exam, basically 1 and 2, and you can. All I would like you to do in number 4, I don't even want you to do number 4, I just want you to look at number 4 and look at all the different symbols that mean tangent line. So what letters could we use that mean slope of tangent line? We have dy dx, don't we? F dash, y dash.
Yep.
What do you think that little line in 4a means? Dy dx line, x equals minus 3. What do you think that means? Any ideas? Yeah. After you find the slope of the tangent, substitute x is minus 3. In other words, it's what is the slope of the tangent line at x is minus 3. That's all. Please note that sometimes people use square brackets. So what you have is dy dx with square brackets, and then it says x equals minus 3 in the corner of the bracket. That's not used so much nowadays. Nowadays, it's usually just the vertical line. Well, I suppose it really depends on who's typing it, okay? Because when you're typing this up, some people are too lazy to find the vertical line on the keyboard, so they just do the square brackets. But it should really be a vertical line, okay? It's the normal thing to use, well, if you're not lazy. Okay, so what I would like you to do, which you can start now for a few minutes, you don't need to do number 4, I just want you to read number 4 to familiarize yourself with the notation. Number 1, I'll give you an easy one and then some hard ones. So, did we do C? We did C. We didn't do C. So your homework for number 1 can be C and then JKL. And then from number 2, we can actually do anything from number 2, I don't think. So just A and B. Okay, then A gives another quadratic. A and I. And I would like you to try your best to do number 3. It's not as difficult as it looks, it's just a bit longer. Yes? Okay, you can start them now. Yes?
X by 5. We use Pascal's
This way?
X by 5.
Oh, you'll have to use the Pascal's triangle, yeah.